Hi, everybody. Welcome to our Math 70 video lecture for section 6.6, which is solving equations graphically or how to use Desmos to solve equations. Because if you're asked to solve equations graphically, unless you already have the graph, use Desmos to graph them. And let me give you an example of already having the graph. One of your homework questions gives you a graph right here, and so you don't need to use Desmos, but other homework questions don't give you a graph, in which case I strongly recommend you use Desmos rather than a separate graphing calculator. I'm just going to go through a couple examples from your homework. The first one is actually the first homework question, or the version that I have. X squared plus 4x minus 3. There's one of our functions. And 2x minus 3. So I happen to have a quadratic function and a linear function, and I want to solve minus x squared plus 4x minus 3 equals 2x minus 3. And what that means is simply find the x values where the functions are equal. And what that means in a graphical context is find the x values where the graphs intersect. Functions are equal when their graphs intersect. And in this case, when you're in Desmos, it's super easy because they show you the intersection points. So if I want to solve negative x squared plus 4x minus 3 equals 2x minus 3, I put them both in Desmos, I click on the intersection points, and that gives me the solutions. 2 and 0. The solutions are x equals 2 and x equals 0, because that's the x values where my graphs intersect. If I'm solving, I don't actually worry about the y values. I don't worry about the 1 or the negative 3. I only care about the x values. All right, let's solve another equation from your homework. Let's solve 0.3x squared plus 0.3x minus 6, and I just want to solve this equation equal to 0. So I want to find the x's, find the x values that make the function equal to 0, and we have a word for that. I want to find the x-intercepts. And we've been doing this for a while now. In Desmos, it's super easy. You just click on the intersection points. -5 and 4. -5 and x equals 4. And that's about all there is to it. You put your equation into Desmos. In this case, there's one equation and I want it to equal 0. I'll give you another example where I have two equations equal to each other. Doesn't really matter if the equations look pretty complicated. What did I do? There we go. 2.3x squared plus 5.06x minus 2.22. That's going to be quadratic. And now I've got a linear equation, minus 4.37x minus 11.19. And I look at my picture and I see they definitely cross. And the nice thing about Desmos is, right, even if you're close to the dot, it'll kind of show up. Oh, this is a good point. Which one's the solution and which one is an x-intercept? Well, let's zoom in. There's a zoom in button. And we'll just zoom in enough until we know for sure, yeah, that's the place where they cross. That's the intersection point. This point's going to show up. This point might show up. The one, yeah, right? Because those are important coordinates, those are x-intercepts, but I'm not looking for the x-intercepts, I'm looking for where the graphs intersect. So my solutions are x equals negative 2.6. That's that x value right there. And zooming back out, x equals negative 1.5. And I can even do this if I have two quadratic functions. So how about I take this quadratic function and now I look at my quadratic function that I started with. Oh, that's cool. This has no solutions. The equation built from these two quadratic functions has no solutions because there are no points of intersection. There is no x value that makes these graphs touch, so there's no solutions. Let's build a slightly different one. Let's do +3. And now I have solutions. They look like they might be irrational numbers or complicated fractions, but that's okay because certainly in your homework, you're allowed to round. 1.10731, x approximately equal to 1.17. Oh, sorry, 1.107, and x approximately equal to negative 1.43. Now, it is likely that on a test, I might give you a question that looks like this one here, where I give you the graph and it's on a grid, so you can see that it intersects twice, and you can figure out that when x equals 0, they intersect, and when x equals 2, they intersect. But I will not on an exam ask you to solve something like this, because the way you solve this is by graphing it. I want you to graph using Desmos, and you won't be using Desmos on your final. All right, that wraps up this video, and it wraps up the final video for the course. Make sure you study for your final exam. The best way to study is by taking those quizzes again. Take your quizzes as often as you want until you're satisfied with your score. Take all of them during the last week, during week 10, to prepare you, because the final exam is going to look very similar to those quizzes. And also, I'm going to make sure that anything on the final exam can be done without using Desmos graphing capabilities. Thanks for watching.